Hello everyone, it's Zenit20, and are you tired of your website lagging and stuttering under some sort of user input? Well, stop what you're doing right now. Every keystroke, click, and scroll calls your registered event listeners, which then call some sort of functions that update the DOM. But if an event fires rapidly, like typing in a search bar, that can slow your sites a lot. Luckily, there are techniques to limit how often your functions execute. Yes, I'm talking about debounce and throttle, the performance methods which even Google uses to make their sites feel instantaneous. Together, debounce and throttle can make your website feel at least twice as fast by reducing function calls, DOM manipulations, and most importantly, API calls. Debouncing and throttling are two techniques to optimize performance in JavaScript by controlling how often functions are executed. Let's go over debounce. Debounce delays function execution, firing their function only after a period of inactivity. This is useful when events happen rapidly, like typing in an input field. With debounce, you wait until the user stops typing for a specified time before executing the function. Now here's a little code snippet of a general debounce function. Let's go over it step by step. The debounce function basically runs a callback function after set time, but will cancel it if it is called again, and then it will set a new one. Thus, only the latest callback runs and previous calls are ignored. That's one reason why we're using the set timeout here. We first assign the timer variable in the debounce function, which will then be available to us for the next call too. Then we return the callback in an arrow function and also within a timeout. We first clear the timeout timer, and thus the previous call to this function is also cancelled. Then we set a new timeout and pass it into our callback with its arguments. Moving out to throttle, throttling limits how often a function can be executed, firing it at most once within a certain time interval. This is useful for continuous events like scrolling or resizing. With throttle, you set a minimum time interval between function calls. So even if the event fires multiple times, the function will only execute once during that interval. Again, here's a code snippet of the general throttle function. Let's go over it step by step. It is similar to the debounce function, but this has a should-wait boolean variable, or basically a flag. In the return function, we check if should-wait flag is true, and if yes, then we return without triggering the callback. If no, then run the callback and make should-wait to true, and in the timeout, bring should-wait back to false. We are simply turning the boolean to true, and the callback doesn't fire as long as the timeout hasn't completed. So now let's switch gears to the code editor, in which I have a real basic setup. In the index.html, we have the input, we have the requested API to track what exactly are we going to ask from our API. We're just having a scenario on which we can work on, and we're also tracking the number of times we are calling the input event and the number of times we're actually requesting from an API. Now, there's of course no real API over here, but it's the best way to illustrate this example. So in the index.js, we have the status element, we have the input element, and we have the request call made, events call made. And then after that, we have two functions which handles the input. And we have an increment event call count, which basically increments the number of times you've called this. So we'll just call the increment event call count over here, which will basically increment this value. And now if we start typing, for example, hello there, you can see that we are requesting from our API single letters. And it is also firing the event 22 times. And it's also requesting from the API 22 times, although we have just typed twice. So that's a really inefficient way of sending API requests to your server, and it can really hang it because of this much load. So to ease this out, we're going to write the debounce function. The debounce function will have the function argument, which is basically a callback function, and a timeout parameter, which will have default value of 1 second. Now we're first of all going to define timer, and then we're going to return in it a function in which we're going to spread our arguments because we don't know the number of arguments. So we have the arguments and we're spreading it using the spread operator. And in this return function, we're first of all going to clear our previous timer, and then we're going to assign a new timer to it with the set timeout. All right, in this, we are going to call our function. And really, that's it. Now we're going to wrap our handle input inside this debounce function. And there you go. One last thing, we're going to add this increment event call count over here. That's for the sake of the demo. Okay. If we now run this, we are going to type, suppose, console. You can see I have typed only 8 times, and only it has requested the word console to the API, like the whole word console. Thus, it has only made one request, and it has batched those 8 requests into a single request. Now, if I'll erase this, you can see again it has batched the request which we have made, and it says just sent one more request. So basically, if I'll keep on typing at the rate of 1 letter per second, you can see it won't be sending anything. But once I'll stop typing, it will send the request. So that's what the debounce does. It basically waits for a certain period of inactivity, and then it sends the request to the API or whatever function you're handling. It will then execute that function. Okay, now let's move on to the throttling. Throttle is exactly same like the debounce. It has the same parameters. We'll take in a callback function, and we'll have a timeout set to 1000, basically 1 second. Okay. In this, we're going to declare, however, a Boolean variable should wait, and we'll set this to false. Then we are going to return a function. We're going to spread the arguments, and we're going to return an arrow function. In this, we are going to, first of all, check if should wait is true, then we return. Otherwise, we execute our function with the arguments. And then we'll turn should wait to true. After that, we'll set our timeout, in which we pass the timeout. And then over here, we're going to call should wait to false. So really simply explaining it, we first of all declare the should wait variable, and then we're going to return a function. And this function, first of all, checks if the should wait is true. So the should wait variable will be accessible to us even in the future calls. That's why the should wait variable will be true in the next call, and then it's going to return. Now, after we have executed if should wait is not true, we execute the rest of this code. And in this, we have the function which will be executed. Now the function is executed, so we should now wait for a certain period of time. And during that certain interval, which is set in the set timeout, it will set the should wait to false after that timeout has stopped. So basically, we're saying that we have run this function. Now we turn the should wait to true, and we wait for 1 second before we turn this back to false. Now we can add one more line of code here, increment event call count, which is just for the demo. And we're going to encapsulate our handle input with the throttle function. And now if you suppose start typing hello there, you can see that it is sending the request in chunks. We have fired the event 16 times, but it has only requested from the API 3 times. Again, if I'll start erasing, you can see that it has been erasing it in chunks. Now, throttling isn't really a useful example for the inputs because end case bugs can happen over here. You can see that our input is empty, but this hello is still there. So usually when you're taking in an input field, debounce is the best option. But if you would like to use throttle, let's move to another kind of event. And instead of listening to the input, we can suppose listen to the mouse move. So we can listen to the mouse move event, and we will listen it on the document. And now if I'll hover over this, I'm hovering over the document. you can see that our input event is being called so many times, but our throttle function is basically throttling it so that we're only sending one function per second. So that's a good way of optimizing. So if you have some event which is being fired rapidly, or you're depending on the mouse move function, it will reduce lag because we're only sending a small number of the requests to the function rather than 1382. The same case can be done with debounce, and I'll illustrate that with the debounce. So suppose I'm hovering my mouse over here on the document. Our input event is continuously being fired, and yet we are not executing our function. Once I stop hovering my mouse, you can see that the request has been made. And there you go. That's debounce and throttling in this video. I hope you had enjoyed it. Make sure you leave a like and subscribe, and I'll see you in the next one.